No,
Yeah, today's the 12th. 11. Oh, you need a pencil. Let me write this down real quick.
how long have you had that?
Long time, dude. This one, probably only 6 or 7 years, but I've been 6, 7. Yeah. I've been using these things for 20 plus years. What?
Thank you.
Yeah.
Oh,
By the way, I'd like to point out that that throw was impeccably perfect and it was, never mind.
I couldn't get used to it. Like you can't.
It takes time. There's a learning curve. And eventually you realize you should just write like you normally do, and then you don't even think about it. So, um, yeah, let's run through some basics first. Let's make sure everyone's up to speed on the just the basics of what square roots are. I don't want to make any assumptions that might make someone feel like left out. So the first number that we generally talk about as being square rootable is 1. And there are others, by the way, like we could say 0 has a square root, but generally 0 is pretty useless in the context of what we're learning today. So rather than focus on 0, we're just going to move on. So the first number on the red list is 1, and the square root of 1 is 1. We have to skip a couple of numbers. Like, why do we skip the square root of 2? Because there isn't one that's not a decimal, right? Like, and this is where we get to talk about, let's make sure all 25 of us in this room understand, what does a square root mean? When I put this symbol and I put a number inside, and don't write this down, like 3, what would I be asking you to find for me? It's not half. That would be divided by 2. It's really important that you make that distinction. What am I asking you when I'm asking you for a square root? Uh, yes. By even, do you mean like the same number? Like equal numbers. Good. The square root by definition means find me something that if I multiply it by itself will make 3. And barring creativity with like other radicals and decimals, it's just not going to happen, right? I could sit here all day and say, I don't know what, like I'm kind of hosed because if I multiply 1 by himself, I get 1. And if I multiply 2 by himself, I get 4, which is why 2 and 3 don't make the cut, because there's nothing times himself that makes 2, and there's nothing times himself that makes 3. So the next number on the red list is 4. Because if I say to you, what number times himself makes 4, you say, oh, 2. And what you find is the number of numbers that you have to skip to get to the next red list number gets longer every time. These numbers are called squares, and they become more and more spaced out as we go down the line. Here we have to skip 5 and 6, bless you, and 7 and 8, and then we get to our good friend Mr. 9. And the square root of 9 is 3, right? Who's the next square rootable number? 16. So you see again, now we had to skip a bunch. So to get from 1 to 4, we only had to skip 2. Then we had to skip 4, and now we had to skip a boatload, right? It just keeps getting bigger and bigger and bigger. Square root of 16 is 4. So rather than continue to write them like this, what I'm going to do is have you write with me for the first time ever the red list. I don't think it's possible to go through this school and not learn about the red list. The red list it's an infinitely long set of numbers that we're going to use today to make our lives hopefully easier. So I'm going to stop. I'm going to abandon writing my numbers like this, and I'm going to start making for you the red list. And at some point, you should make sure that you get a copy of this into your notes. So 1, 4, 9, 16. And you could theoretically just keep looking at the wall. And I honestly don't have any issues with that. That's why I had those young ladies make that red list up there. But see, test yourself and see if you can construct red list numbers just out of what you know about math. Who's after 16? 25. And we can make a solid case for that because the square root of 25 is nice. And now you got to go quite a ways to get to the next good guy. Who is it? 36. Next,
49.
next,
Yeah.
next, next.
100.
Good. And we're only a fourth of the way to our destination, but we're halfway done with the red list, which might sound really weird, but I can say that because the red list numbers start to get so spread out that we're going to make it all the way up to the end. The ending, by the way, for me is 400. It's just where I've always stopped. You could go further to like 441 and so on and so forth, but I like to just stop at 400. It's a good, clean package place to just stop. Who's after 100?
120.
121. After that, after that. This is usually where people slow down. And I'm always proud of your elementary teachers when you slow down here, because that means you generally know your times tables up through 12, which is what someone was supposed to teach you. And now we've left the friendly confines of 12 times 12. What's 13 times 13? 169. And now we're up to 14 times 14, which is 196. And I have never made it through this lesson without having to curve my red list down this way. So I'm warning you, you probably are having better luck than me, but I always have to, I always run myself out of real estate here. What's 15 times 15? 225. 16 times 16, 256. 17 times 17 is 289. And you can see now I am officially out of room. I've taught this lesson 137 times and I just can't find a way to get it to fit. I need a bigger screen is what I need. 18 and 18. Correct. 19 and 19, 361. And 20 and 20 make 400. I will not sit here and tell you that this is the end of the list. This is the end of our memorized list. And these numbers, again, if in case by chance you missed the memo, these are all significant numbers because if I square root them, I get whole numbers, right? Let me just pick some at random and let's write their square roots next to them. Bless you. And I'll have a resource for you tomorrow that's going to help you a lot with this. I'm going to pick one and draw a little arrow by it. Boop, square root, go. Good. So if it helps you, write the square roots right next to them. Here comes another one. Boop. Nice. All right, I'm going to stop making stupid noises. 196. 14. Way to go. 16. 361. Nice. 256.
60.
289. 100. 36. 6. 225.
6.
4. I took one off the list. I don't know if you just watched me kind of ninja stealth vandalize it away, but really it serves no purpose in what we're doing. So don't think of that as being a red list number. It's just like 4 is where we start to really care. So 9. You can fill in the rest of these, can't you? What am I missing? 18, 19. That's it. It would be great if you'd memorize these. And I got to be honest, you will kind of more just because you won't have a choice. Like you're just going to do it so much that you'll just memorize them out of necessity. You're not going to set out to do it. It'll probably just happen. But our time together is going to be better if you just kind of know them, like kind of quick twitch, reflexy thing. So let's get to the purpose on the red list and what we're doing today. So if I asked you a math question, and I'm going to leave this up here like such. If I asked you a math question and said, what's the square root of 121? What would you say? You would say 11. If I asked you a question like, what's the square root of 49? What would you say? Good. The skill I'm about to teach you is a skill that you're going to use all the time in this class. You're going to use it all the time in geometry. You're going to use it all the time in algebra 2. You're going to use it in every math class that you ever take from here on out. So here's the first one that's a little bit of a tricker. What's the square root of 40? Right. There isn't a nice one. This is the first time I'm going to give you a look at something. We have a name for this. It's called irrational. And I don't use that word enough. That's one of it was on my list of things to make sure I do better this year is to make sure you understand what an irrational number is. This is the most concrete example I can give you when kids say, what does irrational mean? Like on the Y top, what are they talking about? Irrational can mean a lot of different things in a lot of different contexts, but the one you're going to see the most is a square root that I can't do. It's going to be an irrational. What it means is if you type this into your calculator and hit enter, it's going to be a decimal of point blah, 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 and it's never going to repeat and it's never going to end. That's what irrational numbers do. Here's what you do. And I want you to follow these directions exact. You're going to start by making a cute little tree like this. Do you remember factor trees back in like fourth grade? Do you remember those? We're going to make a tree. And before we do any math, at the end of each branch, you're going to put a little buck naked square root sign. Just put them there. Don't put anything in them yet. Just put them there. Now, for the first time ever, you and I are going to go through and try to figure out what numbers we ought to put in those two square roots. Now, the thing about square roots is that if you multiply two square roots together, you get another square root. So for example, I wouldn't write this down. If I gave you the square root of 3 and the square root of 6, and I said, hey, multiply those square roots. Newsflash, you get the square root of 3 times 6. So since square roots can be joined that way, they can also be unjoined the other way. So we're taking the number 40 and we're breaking it down into pairs. Now, boy, I hope you're listening. You need to pick a pair of numbers that multiply to make 40, where the one that goes right here is the biggest number on. I'm going to give you 14 seconds to write that down. Write that down. And I pointed very specifically to the first radical, the first square root sign. Your goal is to break down the number 40 as something times something, and you need to make sure that the one that goes in the first one is the biggest possible number you can find off the red list. So I'm going to do something bad. And I know, Jojo, you're just wanting to answer this so bad, buddy, but I'm going to do something bad. Why would I do that? Does anyone know what the square root of 2 is? The square root of 2? There isn't one. How about the square root of 20? There isn't one. Therefore, I chose two numbers like a numbskull. Don't pick two numbers if you're not going to make any progress. Let me give you another pair of numbers that would make me a numbskull. 8 times 5. They make 40, right? What's the square root of 8? I don't know. Square root of 5? I don't know. There is a pair of numbers that I want. And Jojo, do you know what it is?
Oh, no.
Give me a pair. Go. If I put a 4 here and a 10 here, I have found a great combination of numbers because 4 is my friend. He's up on the red list above. What is the square root of 4? Therefore, the answer to the square root of 40 is 2 times the square root of 10. What you're doing today now is the high school version of essentially reducing a fraction. And you know how important it is. If you could go back in time, the day years ago when someone taught you to reduce a fraction, little did you know you'd do it every day. Every day you got to reduce fractions. This is going to become that thing. It's like reducing a fraction. In math, we simplify square roots is what we call this. We're simplifying square roots. Yes, sir.
Wait. Oh. Never mind.
You sure? Let's go again. And I'm going to keep cleaning my workspace, just so you know, because I'm recording all this, so it's whatever. Let's do the square root of 75. What's step 1?
Tree.
Tree. I don't want any talk of numbers until you have 2 branches and 2 square root signs. And I have a very good reason for being a stickler about that. And I'll explain that to you just not right this second. You need to do your blank square root signs. Now it's time to math. I need a good guy number times a leftover trashy number. Have you found it yet? What'd you say? I agree. If I had 75 cents in my pocket, there's a pretty good chance that I have 25-cent coins, 3 of them, right? And what's the square root of 25? So our answer is 5 root 3. That's how math people say it. We don't say 5 times the square root. We just cut it and say 3 quick words, 5 root 3. Boom. 3 syllables into that. Let's go again. Step 1. Get used to it. Branch, branch, root, root. 98's pretty obscure. And this is where you really want to have your calculator with you every day because you're going to be grinding away a lot, testing, can I divide by this? Can I divide by this? Can I divide by this? And I like the challenge of doing it in my head, but not everyone's weird like that. Did you find it?
Maybe
Go for it.
49
Times what?
times 2.
Yes. Great job, Rowdy. Sometimes you got to go way deep into the red list to find your good guy. And I think that was excellently done. What's the square root of 49? So our answer is 7 root 2. You ready for round, I don't know, 4? Here we go. Let's try the square root of 300. This is a trillion times easier than you think it is. Rowdy's already got his hand up.
103.
Is that what you were going for? Anytime you see a number that ends with a pair of zeros, oh, that's the math gods throwing you a sweet bone. You're like, wait a second, I can divide you by 100, and I love 100. So branch, branch, root, root. And I like to make my good guy red and my leftover guy. If you're going to ask me about 4 times 75, fire away. So what I want you to keep doing is making sure that you put the red list number in the first root and the leftover number in the second root. Are you doing that? Let's go. You want to go back to one that we've already done? I would love to answer your question. Okay, let's try another one and see if I can get you on board. Let's do the square root of 24. So the first thing I want you to do is copy that down, and then I want you to go branch, branch, empty root, empty root. Now, what I'm going to do is I'm going to go off to the side here. I think this will help you a lot. Is I'm going to go off to the side now, and I'm going to make a list of every possible pair of numbers that I know multiplies to make 24. So I'm going to start with 2 times 12. And the way I do factor pairs is I work my way up the left side as the right side gets smaller. The next thing I know and you know is that 3 times 8 also makes 24, right? And there's one more, and it's 4 times 6. So far, so good? There are 6 numbers in this box. Which one do you think we like? We like 4 times 6 because 4 is square rootable. If I picked 3 and 8, here's the problem with 3 and 8. Can you take the square root of 3? Can you take the square root of 8? Those numbers are not on the red list, therefore they're of no use to me at all. I want to make sure that I'm only picking numbers that can make me some simplifying square rooting progress. Same thing could be said if I picked 2 times 12. 2 is not up on this red list and 12 is not on the red list, so they're no good to me. But if I pick a 4 and a 6, there's one number here now that I can take the actual square root of. And what is the square root of 4? 2. So I'm going to bring that down now as a 2, and then I'm going to copy down the square root of 6 as the leftover chunky part. Let's keep going. It's going to click hard, I promise.
I understand why, like, where we put that, but what is, like, I don't understand what I mean by it, that on the bottom.
It's just this is exactly the same as this. It's just that the square root of 4 has been evaluated to be equal to 2. It's just all we're doing here is quite literally simplifying. It's no different than if I had a fraction and it was like 18/24, and then I rewrote the fraction as divide them both by 6, and I wrote it as 3/4. All we're doing is just essentially simplifying. So we're taking an ugly radical square root and we're breaking it down into a cleaner version of itself. It's an expectation from this point on. Ask your brother, he'll tell you, we simplify roots literally every day. And we do it this year, we'll do it in Algebra 2, we'll do it in, if you go on to take advanced math, it's just literally an everyday occurrence. And it's no different than simplifying fractions. You can call it reducing if you want to. Let's go again. I'm going to give you one more easy one, and then I'm going to start giving you what we call the death numbers, because I'm down to 5 minutes, so I need to cook. 18. Step 1, branch, branch, root, root. 18 can be broken 2 separate ways. Give me a thumbs up or a thumbs down. 3 times 6. That should be thumbs way down. If I had 4 thumbs, I'd put them all pointed down. Why do 3 and 6 suck? Because you can't root them. Why waste your time on numbers that you can't root? You're not making progress if you can't reduce a root, if you can't take the root. What numbers do I want us to say? Correct. And I don't want them in that order. I want 9 and then 2. And what is the square root of 9?
3.
Therefore, the reduced version of the square root of 18 is 3 root 2. I am now going to introduce you to the death numbers. And I'm going to be as comprehensive and thorough about this as I can. The first number I'm going to put up here, you're going to think, you got to be kidding me. How is this an actual, like, are you trying to scare me? 32 is the first one that gets missed 587,000 times a year. Huh?
Is that actually true?
Nope.
You
Yep.
told that I-
Yep. What did you just say?
Oh,
You said something really good.
6 and 2.
Yes. And here's the problem with 32. Most people who made it through elementary school are going to do this. 4 times 8. But you remember earlier in the notes when I pointed at this, I didn't just say any old number you want off the red list. I want the biggest number off the red list. And 4 times 8 is the quickest low-hangingest piece of fruit. You're like, oh, what a cute little piece of fruit. The trouble with it is, had I taken the time to delve deeper into the list, I'd have realized there's a way bigger prize. 16. Excellent job spotting that, by the way. So we're not going to use 4 and 8. We're going to use 16 and 2. And what is our final answer? 4 root 2. People sometimes say, well, can't you break down 4? And I'm like, no, you crackhead. It's not a square root of 4. It's just a 4, right? You don't get to square root it and then root it again just because you feel like it. Once you root it, it's dead. Here's another death number before we are through here for the day. And again, you might wonder, like, is seriously? Yeah, 48. And I'll tell you the reason it's a death number is because The low hanging piece of fruit, I'll take one for the team here, is 4 times 12.
16 again.
It is 16 again. 16 is a booger. 4 times 12 works, but it's like reducing a fraction and not finishing. Like, why would you start to reduce it and not finish? So rather than put ourselves in that position, we're going to dig deeper down the red list and realize, hang on, 16 times 3 makes 48. And what is the square root of 16? 4 root 3. At this point, we have 1 minute and 25 seconds until the bell. I'm going to pull your assignment off of Delta Math, and we're going to start tomorrow with 4 or 5 more examples. And then after that, we can work on our super long assignment. Got it? And if I see you in the hall later today, I might just give you one and just walk up to you and say, oh, hey, Kobe, square root of 27. And I expect you to go, oh, 3 root 3. I got this. I was like, Garrett, the square root of 20. He's going, oh, 2 root 5. Easy. For me. Say, Michaela, what's the square root of 200? 10 root 2. Right? Good.
I thought I got it.